Hi everyone. In this week lab, which I believe is a continuation of last week lab, I learned a couple of new things which I'm going to be sharing with you. First, I would like to remind us the definition of a precipitation reaction. Precipitation reaction is the formation of insoluble salts when two solutions containing soluble salts are combined. When the insoluble salt falls out of solution, it's known as precipitates. Precipitation has its usefulness. It could even be used in the real life. It could be used in wastewater treatment where we precipitate contaminated ions. It could be used in silver nitride and potassium chloride, which is a very great example of precipitation reaction. Oh, common examples of it are like rain and snow, though we do not have snow in California, but snow in New York. And it could precipitation reactions determine presence of various ions in solutions. And putting it in a layman way, I would just say precipitation is basically the creation of solid from a solution, a solid from a solution. So using Beyond Labs, we did the I have a question to answer from the Beyond Lab assessment, the number 3. But first, I would like to tell you something I learned, the fun stuff I learned. The rules for getting a net ionic equation, that's NIE for the abbreviation. You balance your equation. Let's say, okay, I kind of explained how you balance the equation in the last video, but you balance the equation, you give the states to each substance. You split the strong electrolytes into ions, cancel out the similar ones, which I said was the yeah, and then you write the ionic equation with the remaining ions and substances. When balancing equation, we need to take care that all elements in the reactant and product side are equal. And this side, when you cross it to the side, you have to make sure they're equal. Uh, Milky, when you say like in this like for the M of my assignment was milky white. The precipitate, the color was milky white. It was milky white. It entails possible precipitate, meaning solution was not that clear. So that's just what. In the space grade D, where no reaction occurred, it has which also occurred in the space grade H, L, N, and O. Any chemical reaction illustrates any type of charge change in system like oxidation or reduction, substitution or elimination. But if no reaction occurs, that means no product is formed, which means the components which are left of arrow on the right side, that is the product side from the reactant side. It's the waste of it wastes the sole logic of writing a chemical reaction. That's why it's not necessary to write a chemical reaction if no reaction occurs. That's the NR. Like in the question was what happened in grade space D. What other reaction gave similar results, which I just said, and is it necessary to write a reaction when no reaction occurs? If there's no reaction, you do not write the reaction because you're not, because the compounds are soluble in water, then there's no precipitant, meaning no reaction in the grid space D. And in that case, there's no need to write the equation, as you are spoiling the main purpose, the main reason of writing a chemical reaction. Thank you.